The additive identity property says that adding 0 to a value does not change the value. More precisely, a plus 0 equals a. Here are some examples. 3 plus 0 equals 3. 90 plus 0 equals 90. And x plus y plus 0 equals x plus y. The commutative property of addition says that swapping the terms of an addition operation does not change the sum or output. More precisely, a plus b is equal to b plus a. Here are some examples. 5 plus 7 equals 7 plus 5. X plus y is equal to y plus x. And m times n plus 2 is equal to 2 plus m times n. The associative property of addition says that when adding three terms, changing the order of operations does not change the outcome. More precisely, a plus b plus c is equal to a plus b plus c. Here are some examples. 5 plus 7 plus 9 is equal to 5 plus 7 plus 9. X plus 1 plus c is equal to x plus 1 plus c. And finally, m times n plus 2 plus j times k is equal to m times n plus 2 plus j times k. Subtracting a number is the same as adding the inverse of that number. More precisely, a minus b is equal to a plus b times negative 1. Here are some examples. 5 minus 7 is equal to 5 plus 7 times negative 1. X minus y is equal to x plus y times negative 1. And m times n minus 2 is equal to m times n plus 2 times negative 1. The additive inverse property says that the sum of a value with its additive inverse is 0. More precisely, a plus a times negative 1 is 0. Here are some examples. 3 plus 3 times negative 1 equals 0. 90 plus 90 times negative 1 is also 0. And finally, x plus y plus x plus y times negative 1 equals 0. The additive property of equality allows us to add a value to each side of an equation. More precisely, if a is equal to b, then a plus c is equal to b plus c. If some equation is true, then it will stay true after we add a value to each side. In Logic Walk, this property is actually an example of substitution, but since it is commonly labeled a property, we will adopt the same naming convention. Here are some examples. If x is equal to y, then x plus 3 equals y plus 3. If I plus 1 is j, then I plus 1 plus k is equal to j plus k. Finally, if distance between a and b is equal to the distance between x and y, then distance from a to b plus 11 is equal to distance from x to y plus 11. Let's use the properties we've learned so far to prove the following theorem. If a plus 90 equals 180, then a is equal to 90. First, we use the additive property of equality to claim that a plus 90 plus negative 90 is equal to 180 plus negative 90. Then we show that the left side reduces to a, and the right side reduces to 90. Let's go through the proof. We're given that a plus 90 equals 180. In step 1, we use the additive property of equality to claim that a plus 90 plus negative 90 is equal to 180 plus negative 90. In steps 2 through 7, we show that a plus 90 plus negative 90 equals a, because 90 plus negative 90 is 0. In step 8, we use the fixed value statement property to claim that 180 plus negative 90 equals 90. Finally, Since a plus 90 plus negative 90 equals 180 plus negative 90, and a plus 90 plus negative 90 equals a, so the left side is a, and 180 plus negative 90 equals 90, so the right side is 90. We can conclude that a is equal to 90 using the transitive property.